So we are going to find complex roots. Complex means real and imaginary roots. So to do that, what we do is we set each factor equal to 0 and solve them. So make sure you write small on your piece of paper so you can fit it nicely. So I'm going to set this equal to 0 and solve it. I'm going to set this equal to 0 and solve it. And I'm going to set this equal to 0 and solve it. Do you see how I set each factor or each parenthesis piece equal to 0 to solve them? Now, let's solve each of these and see what the complex roots are. So for this first one, I'm going to minus 7 over. So I got 3x equals negative 7. Then I'm going to divide by 3. And I get x equals negative 2 1/3. And then I'm going to plot that. Negative 2 1/3 is right there. It's a little bit farther than negative 2, but not all the way to negative 3, closer to negative 2. And that is one of my complex roots. All right, let's solve this one right here. So we're going to minus the 16 over. I got x squared equals negative 16. I'm going to square root both sides. And I get x equals positive or negative 4i. That right there is a complex or an imaginary or two imaginary values. Because you cannot square root a negative. But if you do change them to imaginaries, that would be square root of 16 is 4i, positive or negative. Now, can I plot positive, negative 4i? No, they're imaginaries. They don't exist on the real number line. So those are just kind of figurative answers. They're imaginary answers. You can't plot them as actual zeros. Let's solve the last one here. So we're going to add 9 over. So I got x squared equals 9. I'm going to square root both sides. So I have x equals positive or negative 3. Now these are real zeros. These you can plot. So I'm going to go plot them. I'm going to plot negative 3, and I'm going to plot positive 3. Interesting. I just plotted 3 zeros, but there's actually 5 complex roots. Because these two imaginaries are roots, just like these, they're just not plottable. Here's something I also want to point out. Do you notice this is a 5th degree polynomial? 1, 2, 3, 4, 5. A 5th degree will always have 5 complex roots because some of them could be imaginary. And that's something we didn't catch on to in Unit 1. Unit 1, we didn't talk about imaginary roots. So why, whatever your degree is, if your degree was a 4th degree, there are 4 complex roots. It's just some of them could be imaginary. That's why they're missing. Some of them could be bounces. There's different things that could be happening. All right? So you have to be aware that sometimes you have these imaginary roots that are missing. So we plotted those. Our next step is to use a graphing calculator to graph this and see how it goes through these dots. Because you probably don't know what it looks like. What is this imaginary doing to the graph? The graphing calculator tells. So let's graph it on our graphing calculator. Let's sketch a generic sketch of it that goes through these 3 real roots. So when you do the graphing calculator, you will see a sketch of it, a graph. Now on this, I just want to make sure it hits these dots and the maxes and mins are about where they should be. So if you look at between these 2 dots, does it go up or does it go under? And what you should know, it goes up. And if you look at it carefully, does it reach 1 or does it just a little bit below 1?
Below.
And what you'll notice is it goes slightly below 1. So it's going to look kind of like that. And it goes like this. Now the next one, it's going to go down and back up. Now how down did it go? Well, it went off the screen, didn't it? So is it going to be below this point down here? Is it going to go below 10? Yeah, so what I'm going to do here is I'm just going to, okay, it's going to go down here, off quite a bit, and come back up. And does that kind of look like what your graphing calculator showed? I just want about, where are your max and mins about between the dots, so I can see that you actually looked at the graph and didn't just throw something on. So that looks kind of like what your graphing calculator showed you. We don't know exactly what it looks like. Now, again, these right here are imaginary roots. I want all 5 complex roots listed, because we're looking for complex, but we only graph the reals.